All right, everyone. So today we are going to talk about the layers of the earth. As you can see right here are the copy of my notes that you also have access to. I took this from the article that is attached in Google Classroom. What's it called? I don't know, something Earth layers, everything you need to know, or something like that. Okay, so let's start from the center and work our way out. Now, this is not to scale, meaning it is not the exact proportions, but it is kind of close. You have the inner core and the outer core, and the outer core is bigger than the inner core. The mantle is much thicker than any of the other layers, and the crust is very, 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 very thin. Okay. In fact, if I were to make this a little bit more proportional, you wouldn't even really see the crust because it's that thin. So there is not a third layer up here. It's me not being able to draw a perfect circle. So there you go. But you guys are used to that by now. All right, so starting at the bottom and working our way out, we have the inner core. The inner core is very hot, like 9,000, almost 10,000 degrees Fahrenheit hot, as in almost surface of the sun hot, okay? So it is super, super, super hot, but there is also a ton of pressure, exactly about 3 million times what there is on the surface of the earth. So we do experience pressure, air pressure. There is in the atmosphere, we learned about this, there's layers of the atmosphere that are pushing down on us, and that gives pressure. Now, if you are at the inner core of the earth, you have everything above you pushing down. Also, you have to remember up here is also layers of the atmosphere. So everything related to planet Earth is pushing down on the inner core. So there is a extreme, I don't think the word extreme really is extreme enough, how much pressure there is. There is so much pressure that actually contributes to the temperature of the inner core. Now, the inner core is solid metal. Specifically, it's iron and nickel. Those are two very, what they call heavy metals. They're very, very dense. And we talked about density with the atmosphere. That density is how much matter there is in a given space. So if something is very, very dense, those atoms are very closely packed together. And the temperature of this is so hot that in reality, it should not be a metal. It is way past melting point, which is when you go from a solid to a liquid. But there's so much pressure here in the inner core that it's compressing it, and it's like you only have this much space to work with. So it's so compressed and so much pressure that it's actually forcing it into a solid. Okay, so a very unique feature about the inner core. And actually in that article they talked about, and I didn't know this, but scientists think there is actually another inner core, like even the inner core itself has another part to it. All right, so kind of interesting. The outer core is also metal. It's also iron and nickel, which again are those very heavy metals. But the outer core, this is liquid. It's still hot. Okay, it's not quite that hot, but it's still like really hot. Like, don't even ask me, would you die if you went there? Yes, you'd be dead long before you got there. The interesting part about the outer core is since it's liquid, and we've talked about convection currents before, there is what causes the heat that's generated in the outer core is radioactive decay. Radioactive decay is essentially the same thing, kind of, that happens in nuclear power, things like uranium and stuff like that breaking down, and it gives off heat. Okay, so that heat that's given off, there's unequal heating in here. There's areas where there's more uranium and it's decaying faster, so you have a hot spot compared to something else. Again, it's still hot. It's all relative. Okay, so what this does is this creates those convection currents. Again, hot things rise, cold things sink. And it's not so much they rise or sink because of the temperature, they rise and sink because of density. Hotter things are less dense, cooler things are more dense. So it's going to rise up and fall. This movement of this liquid metal creates an electrical current. It's the same concept as how we make electricity with water flowing over big giant fans called turbines, or turbines, and it spins those turbine fans and it creates electricity. This churning in the outer core creates the magnetic field, which is a huge thing. Literally size-wise is very big, but it's also incredibly important to our planet that we have a magnetic field. This magnetic field, well, it's what makes your compasses work and things like that, and some of our electronics and stuff like that. But in reality, the fact that our planet has a magnetic field is one of the things that allows life to continue on this planet. Mars does not have a magnetic field anymore, or if it does, it's tiny, okay? Magnetic fields on planets act like force fields. What they do is they deflect some of the radiation that gets shot out from our sun. Every star does it, and the magnetic field, it literally deflects it, okay? Without this, we would be blasted by what's called the solar wind, okay? The mantle is the thickest layer of the Earth. This is the part that we tend to think about the most when we talk about layers of the Earth. The mantle is where I'm going to find the magma. It's kind of liquid, kind of solid, okay? It's more like, they use the example of semi-solid, like caramel, however you say it. It's not quite runny liquid. I think of this as the mantle is more of like hot fudge. Not when it is like hot fudge on the ice cream. It's starting to cool off, and so it's kind of globby and I can't talk. It's kind of globby. So it will still flow. Like if I picked it up on my spoon and I went to like have it drip off, it would still drip off, but it's really slow. Okay. Maybe pancake syrup. I'm trying to think of something else that might work. Honey. Okay. Not like super hot, runny honey, but it's a little thicker. Okay, so we have convection currents in the outer core because it is a liquid. We're also going to have convection currents in the mantle. However, these currents circulate much slower than here in the outer core. Oh, by the way, the inner core is also spinning. Okay, it's spinning as a solid, so think of like a basketball spinning on your finger. Okay. The crust. The crust is like the shell of a hard-boiled egg. Okay, so if you think of the shell of a hard-boiled egg, it's really thin, it's really brittle, and it can be broken up into pieces pretty easily. And you can break a hole in the shell of the egg and get to the stuff underneath. Okay. The crust of the Earth, so it is really thin, but the thickness is going to change around the planet. The crust is really thin. There's two types of crust, sorry. The first type is oceanic crust, and the second type is continental crust. Oceanic crust, just like it sounds, it's the crust that's underneath the ocean, and it is very thin. And if you think about how much water weighs, like you've ever had to fill a bucket of water up and pick it up, you think, oh, this is super light. And you go to pick it up and you realize this isn't as light as I thought it was going to be. Water has an immense amount of weight and pressure. And so if you have crust at the bottom of the ocean, it really does get pushed down, and pressure is applied to it from the top. So if you think of like when you played with Play-Doh and you used to take the rolling pin or your hand or whatever and you would push down and it would get super, super, super thin, that's like the oceanic crust. Continental crust, this crust is much thicker. Now remember, continents are land. So continental crust is crust that has land on it. Now you might have lakes, you might have part of an ocean, okay, like the coast of California, okay, or the Gulf of Mexico or something like that. But for the most part, when you're talking about continental crust, the majority of that crust is going to be dry land with lakes and rivers, and that's okay. This type of crust is going to be much thicker, especially where you have mountain ranges. And if you think about it, it kind of makes sense because this is all rock. Guys, crust is rock. All three types. All right. This type is melted rock. These two are metal. Okay. So if I really quickly look at, I like this one. So this image right here shows me the different layers of the earth. Now, if you're like, wait a second here, there's only 4 on our notes, and here's 1, 2, 3, 4, 5. Okay, this layer right here, this is a special type of layer that's called the asthenosphere. What this is this is where the upper part, I can't see my, there we go. The upper part of the mantle and the crust start to meet, okay? So if you want to think about this upper part of the mantle, it's really starting to cool off. So it's not, because it's much more solid than the mantle that's closer to the outer core. So it's really just kind of sticky, kind of like glue. So this part of the mantle, the asthenosphere, it will stick to the bottom of pieces of the crust called tectonic plates, and we're going to get into that next, so don't worry about it quite yet. This part of the mantle will stick to those pieces of crust and move around with it. So that's why this picture is like this. And if you look really close, can I zoom in? Can I zoom in? Yes, I can zoom in. Okay. If you, stop it. Sorry. Let's go back. Stop. Let's try this again. Is it not going to work? Okay. Oh, there we go. So if you look closely, you can see where it's all cracked into pieces. Okay. So there's that. All right, so convection currents. Now, I'm going to show this to you. I know you're not going to hear any sound, and that's okay because it sounds really awful. But what this are is just a review for you of convection. So this is demos from a chemistry class. Now, remember, convection is when you have uneven heating in a fluid. Now, we've talked about fluids. We always think of fluids as liquids because they say, oh, make sure you drink your fluids. Well, that's true, but fluids also technically are gas, not gasoline that goes in your car, but gas as in solid liquid gas. All right, so if you look at him right here, he's just adding some food coloring essentially to this little tiny flask, and it's really hot. It's getting hot now. So he added this red food coloring, or red dye, essentially, to the liquid. He's heating it up. He doesn't want it to boil, but he's going to take that and he's going to stick it into this larger container. It's just water. It's cool water. Okay, it's not ice water. It doesn't have any ice cubes floating in it. But you'll see the bubbles start to come up. And you're going to see that red liquid start to come out. And notice how it's going across the top. There we go. And it's coming out, heated water rises, so it's going to stay up there close to the top of the container there. And he's going to speed it up. And you can see that here before too long. Okay, I'm jumping in collisions. All right, here we go. So he's going to add an ice cube, and I want you to look right over here. Notice it starts to come down over here. Not over here, but over here. And he's going to speed this up a little bit. So we added the red coloring so that you could see this. If this was all normal water without the coloring, there is no way you could see any of it happening. And if you look here, it's going down there. And when it hits that, when the colder water that's diving down to the bottom, when it gets closer to that smaller container that has this, if you look closely, you'll see not coming directly out of the container. I'm sorry, I could talk, it'd help. But as it hits down here, it's going to warm back up. Now this flow is going to stop, here's this word, when equilibrium is reached. That means when the temperature of all the water is basically balanced out, you're going to stop. Here's another one that he has. You could do this, well, maybe not at home. But what this liquid, is kind of like a shampoo. So there's certain types of shampoo, usually the ones that have like, I used to do this demo in class, and it's the shampoo that has a shampoo and conditioner in it. So it's got that shimmery look to it. You'll see it coming up. Now you'll notice that it's not like everything's not going in the same direction. There's different currents happening. If you boil a pot of water to make macaroni and cheese, oh yeah, here you go. So you're going to get bubbles in other places in there. So there's uneven heating of that water. It could be from the pan. It could be of where it's touching the heat source. He's using like a natural gas or propane type Bunsen burner. And so I'm guessing this part, the left side of the beaker, is sitting right over the top of that flame. So there's more intense heat than compared to the right side of it. So there's that. So those are just some quick examples for convection. And we had our notes here. So I hope this helped understand the different layers of the earth. Talk to you guys later. Have a great day.